Hello everyone, I'm Fangdan Ye from Tsinghua University. Today I'm going to talk about Huoyan, a practical configuration verifier on Alibaba's Global WAN. This work was done when I was an intern at Alibaba Group. As one of the largest service providers, Alibaba has a global network infrastructure to serve over 1 billion customers worldwide with its online services, such as cloud service, e-commerce, e-payment, online maps, and so on. Maintaining the configuration of Alibaba's network, especially our global WAN, is extremely challenging because our WAN not only contains a large number of routers and IP prefixes, but also involves many protocols, including BGP, IGP, static routes, as well as ACL rules. To prevent the incidents resulting from network misconfiguration, Alibaba decided to adopt network verification to prevent configuration-induced incidents ahead of time. Our verification system is named 火眼金睛. This name is from the skill of the Monkey King in ancient Chinese myths, which means the Monkey King can see the truth through his fire and golden eye. In SIGCOMM last year, we have presented our ACL verification work, 金睛. Today I'm going to talk about 火眼, the routing configuration verification system. Building 火眼 system requires us to address two technical challenges. The first challenge is how to reason about the properties of our global WAN in a scalable way, especially when considering failure case. We call the reachability under failure case as k-failure property, which means whether the reachability holds if arbitrary k links or nodes fail. In the first example, k should be 1, because if the link between D and E fails, the original reachability no longer holds. In the second example, k is 2, because if these two links fail, the reachability is violated. However, reasoning about the k-failure property in our WAN is hard. First, existing simulation-based verification approaches like Batfish need to enumerate all possible cases, which has exponential complexity. Second, the state-of-art formal model verifications like Minesweeper generate a huge SMT formula for a large-scale network. Solving such a huge formula is time-consuming. Finally, because our WAN is not symmetrical, the existing reduction and simplification approaches like bonsai do not help neither. The second challenge is the network model may not accurately represent the real network behaviors due to vendor-specific behaviors. Let me show you a real example for vendor-specific behavior. In the example, we have 4 routers. Router 1, 3, and 4 are provided by vendor A, and router 2 is from vendor B. Suppose two prefixes, 10/8 and 20/8 arrive. R1 adds a community to them and sends them to R2. R2 keeps the community, then comes R3. R3 tries to add community to prefix 20/8, but finds it already exists. Finally, R4 accepts both of the prefixes and generates the routing table. Unbeknownst to us, R2 in reality is from different vendor from R1, R3, and R4. It has a latent vendor-specific behavior which removes community or BGP updates. In this case, two prefixes arrive. R1 adds the community to them and sends them to R2. R2 drops the community, then comes R3. R3 adds community only to prefix 20/8. Finally, R4 only accepts prefix 20/8. We eventually get a different routing table in reality, which is different from our simulation result. So, when the specific behaviors can significantly affect the accuracy of our network model, thus making our verification results inaccurate. When the specific behaviors exist because of the ambiguity of RFC, no existing verification system can detect the vendor-specific behaviors. 火眼 is built to offer configuration verification to our WAN and addresses the above two challenges. To use 火眼 system, the operator sends a verification query to the system. Then, 火眼 generates a network behavior model. With this network model, 火眼 reasons about whether the network model meets the input property. The blue part is called configuration verifier, which focuses on reasoning about the configuration correctness in a scalable way. This is our first innovation design to address the first challenge. In order to ensure the correctness of network behavior model, We also equip Huoyan with behavior model evaluator to tune the network model in a periodic way. The gray part is called model tuner, which is responsible for ensuring the accuracy of generated behavior model. It addresses our second challenge. Let me first show you how to address the scalability challenge. To address the scalability challenge, our insight includes the following. Simulation-based approaches like Batfish are scalable in large network, but are slow in handling some properties such as k-failure tolerance. On the other hand, formal model approaches like Minesweeper can verify any property well, but are not scalable to large networks. So, we propose a combination solution named global simulation and local formal modeling. Our approach runs overall simulation for global scalability. At the same time, each router node in our network model locally encodes its all possible routing conditions that are transmitted along with the simulation process. To avoid the encoded formula becomes larger at the simulation process, we also introduce many optimization techniques, including pruning unrelated parts of the formula, dropping impossible cases, and simplifying the formulas. We chose a subnetwork containing 80 routers in R1 to compare Huoyan with the state-of-art efforts like Batfish and Minesweeper. As shown in this table, we failed to get results from Batfish or Minesweeper when we tried to reason about the k-failure tolerance property, but Huoyan returned results in reasonable time. Now, let me show you how do we address the model accuracy challenge. To address the second challenge, we built a device behavior model tuner which uses a production network as a reference for our simulated model debugging. This model tuner periodically checks the difference between the real-world routing tables and simulated routing tables to localize the vendor-specific behaviors. A strawman solution is once the difference between real and simulated routing tables is detected, say R4's routing table. The model tuner backtraces the path until a router whose routing table is the same, say R3 in this example. The vendor-specific behavior should be in R3's egress policy or R4's ingress policy. Unfortunately, using normal reefs cannot localize the correct vendor-specific behaviors in practice, since normal reefs lack of much useful information for the reference. Therefore, our tuner uses extended reefs rather than normal reefs. With extended reefs, the model tuner can correctly detect R3's extended routing tables between real and simulation are different. So the vendor-specific behavior actually exists in R2's egress or R3's ingress. Our model tuner detected 8 VSBs by far, including default ACL, root policy, and so on. Because of these VSBs, the early version of Huoyan has poor accuracy. As shown in this picture, after use our model tuner 6 months, the accuracy of Huoyan has been near 100%. Huoyan has been used in Alibaba's Global WAN for about 2 years. The overall rate of update-triggered network incidents was cut by more than half in the second year of Huoyan's deployment. During the 2 years, it detected many potential configuration errors hiding our network, such as IP address conflicts and redundant device misconfiguration. In the last year, Huoyan was also used to check our configuration update plans before they are committed to the network. Now, let me clarify the capability scope of Huoyan. What protocols does Huoyan support? Huoyan can reason about eBGP, iBGP, is, OSPF, static routes, route redistribution, and ACL verification in R1. What network properties can Huoyan reason about? According to our operation needs, Huoyan can verify properties including reachability, k-failure tolerance, non-deterministic routing rates, and path consistency. In conclusion, Huoyan is the first ever reported practical configuration verification system deployed on Alibaba's Global WAN. It addresses the challenges on accuracy, scalability, and coverage, and has been used in Ali Cloud for 2 years. This is the end of my talk. I'm happy to take any questions. Thanks.
Thank you for a really nice talk. Let's wait for questions on the Slack. In the meanwhile, maybe I will start with one question. Hi, Annan. So the question is, how does your design relate to the RIP sizes? Like, would you see any performance problems with different like larger RIP sizes?
That's a great question. So actually, in Alibaba Cloud, we have a super large scale RIBs, but unfortunately, we cannot directly simulate the entire RIBs. That would be horrible. It's very expensive. So yeah, our work, we actually do the simulation for each specific prefix. So for each prefix, actually, the RIB is not super large, and we can just simulate each prefix in a parallel way. And in that case, our system, could efficiently handle all the cases rather than just directly, pull all the entire RIBs from our routers. That will crash our router, make it down. That's a great question.
Okay, so the next question is from Aditya Keller from Wisconsin. His question is, have you in Alibaba production network, have you thought about applying tiramisu or ARC kind of password? Like, what are the unique about Alibaba's network that make it?
Yeah, thank you very much for the question. That's an excellent question. Actually, before we submit the paper, we really wanted to deploy the tiramisu in our global WAN. But unfortunately, at that time, I sent email, but it was not open source at that time, and so we have to try to reproduce the tiramisu in our environment. However, we failed to do that, so we gave up. And after the paper got accepted, we didn't. I'm sorry.
Technical differences. Like, do you see any technical differences that prevent us from?
Right. So I think. Yeah, I think that's a great work. The technical difference might be so I think for the verification part, our system used the simulation, but tiramisu is designed based on the graph-based algorithm, something like that. Because we didn't truly compare them because we didn't get the code, so that's the key reason. So we will absolutely try that because I noticed it's open source now. But I have to explain why we didn't compare it before I will submit the paper. And yeah, so we'll definitely use that. But for ARC, I think ARC. So I guess it's kind of limited to the OSPF protocol, not rather than BGP protocol. So because in our network we have a lot, mainly use the BGP protocols. So that's the reason we cannot use the ARC to compare with the WAN. But we will absolutely consider the tiramisu in the future. Yeah, thanks for the question.
Great.
Yeah.
The last question is from Sanjay, which is, since you will have some operational experience in Alibaba, can you give the community some open questions, like what are the unsolved questions that matters for operational networks?
Yeah, that's an excellent question. Actually, we have a lot of real experience. I just want to say something. So hopefully that will be important. So first, I think in our experience, I think scalability is the most important thing. And sometimes we want to use, say, the SMT formula or some other formula-based approach to verify the network. However, the real network is super large, and sometimes the scalability is not well for some existing work. So in that case, we have to propose the first of the highest priority is the scalability. The second thing I really want to emphasize is a lot of existing verification system didn't focus on the accuracy of the verification system itself. So you are the verifier and you want to find a bug, but if you have a bug, how to solve that problem? So that's the reason we shared our model tuner, but I guess that's just a starting point. So I want to see a lot of following up work after that direction. I think the final suggestion is, so for our operators, it's very difficult to write the specification. And I also noticed a lot of existing work in the, proposing the new specification language. That's a great thing, but I really hope to see, more work in that direction, because for our operators, it's really, really hard for them to write the specification in first order logic. That's difficult because they do not want to use that that type of language to write the specification. So we have to provide some graphic based interface for them. So if we could propose some very easy way for them to write the specification, that will be very useful.
Right.
Yeah.
Thank you very much. I'm sure we will have more discussion. It'd be really nice to have more discussion between industry and academia on verification. Yep. Slack. Yeah, let's continue this on Slack.
All right. Thank you for a really nice talk and really impressive tour de force. Amazing effort. It's great to see something so comprehensive.
Thanks.
I have a first question. So this idea of using a model tuner to help sort through the vendor-specific behaviors seems pretty cool. I didn't quite follow how automated it is. So how much does the person driving the model tuner need to provide input in order to, say, expand the routing tables and maybe interpret the traces that come back?
Oh, that's a great question. So yeah, this is a very important thing for Huoyan because so we build the model tuner, and so we run it in a periodic way. So every day, say the model tuner is running to timely check the our routing table to compare the routing table with our simulated tables. But after the model tuner detects any difference between the simulated routing table and the real routing table, it sends a report to our operators. So before sending the report, all the process is automatic. So that means they automatically run the model tuner, always. However, after sending the report to the operator should, manually check, to manually write the patch for the vendor-specific behaviors, because we can, so far the Huoyan cannot automatically generate the patch to fix the vendor-specific. It can directly detect where is the vendor-specific behaviors, but it cannot generate the fixing. So generate the fixing should be manually done. So this part is manually done. And after the operators create the patch, and they can put a patch in the model. So in that case, everything's done. So yeah, it becomes automatic again. So this is the whole loop.
Great. Let's see. I don't see any other questions on Slack. So if folks are asking and being shy, we have time for maybe one more question before we have to sign off. If not, I will ask one. Also this way of partitioning the work between sort of a simulation-based approach and an analysis-based approach seems very pragmatic. Is that also sort of fully automated, or again, is there a human driver who has to guide the tool down those paths?
Yeah, so that process is totally automatic way, and we didn't do manually insert anything during that process.
Great. I'll ask one quick question, and then we're really done. So what's next for Huoyan? It sounds like you have 2 years of operational experience and great performance. Is it more properties, richer properties? Yeah. What comes next?
That's a great question. So we're planning to do several things. First, we may want to add some quantitative properties, like so I want to check the reachability for some traffic, not just whether the router could be arrived or not. Then we want to check whether this traffic, how many traffics will arrive, and how many traffics cannot be arriving. This is the first part. I think the second part is we want to kind of deploy the Huoyan on, say, some emulator. So the emulator is able to check some problems resulting from the bugs, but for verification system itself, it cannot detect the bugs. So we want to combine the emulator and Huoyan verification. So in that case, we could provide a comprehensive verification effort to our network. So that might be 2 steps in our future. So we'll absolutely do that in the future direction. The great question.